Good morning, everybody. My name is Jeremy Gibango Cantin, and today I will assist you with fourier series. Please, I want to insist about something. People who are doing engineering math 2, alright, a TUT, you do not have the formula sheet of fourier series, alright. They give you for integration, but they do not give you for fourier series, alright. So you have to know it, alright. By definition, f of t is equal to what? It's equal to a0 divided by 2, alright, plus the summation n starting from 1 to infinity, alright, you must know it. And then you have a always go with cos, alright, cos of n pi t divided by L plus summation, I'm gonna write it right here, plus summation of n from n equal to n to infinity of b n sine n pi t over L. Please, you have to know this by heart. And then we need to know what is a0, an, and bn. Those are the constant, and then we need to find them. How do I find them? I have a0 is equal to what? It's equal to 1 over L integral from minus L to L. I'm going to explain to you what is this. F of t dt. All right, so this is your a0. My a n will be equal to 1 over L. It's very simple, minus L to L. I'm gonna have f of t, and we know a goes with cos n pi t over L dt. All right, and then my b, all right, my bn will be equal to 1 over L, all right, f of t cos, oh sorry, look at this paper, it's very nice. I can clean it like this. See, b goes with sine always. All right, okay, there you go. Those are the basic stuff that you have to know it. You have to know it. Now, there is what we call particular cases. Particular cases is when you have a even or odd function. And how do you know a function is an even, or when is, how do you know it's odd or even? All right, let's see this. I'm gonna show something. This is my graph. All right, a cos starts from like this. All right, this is a cos. All right, okay, but I would like to write it. This is cos, right? You know that from 0 it's 1 there. Okay, if it was going this way, even, look at this. This is your y-axis and this is your t-axis. Okay, normally, okay, y and x. All right, this is your, okay, let me do this. All right, this is your vertical axis. This is vertical, right? Vertical, look at it, vertical. And this is what? Horizontal. Now, for you to know which one is odd and which one is even, you will check this letters, the second letter. Vertical, it's E is coming, it's even, and O is odd. So by definition, a function is even, looking from the graph, if it is symmetrical about the y axis or the vertical axis, and then it's is odd when is symmetrical about the origin. They call it origin. All right, so look at this one. For example, this cos, if I flip it like this, if you close this paper, you'll find that this it's gonna lie, it's a mirror image. You can see that this is repeating this side. You see that? Yes, it is a even function. So you cannot have a function which is both even and odd at the same time. No, it's either it's even or odd. All right, if it's not even and it's not odd, we call it neither. Okay, it's neither even and neither odd. So when you come across a function which is not odd and is not even, then you go back, you do the general, so you find it this way. All right, so I'll quickly show you this. It's exactly the same thing that I'm having here. All right, same thing, and I don't want to write this down again. All right, when a function is even, you're gonna have a0 equal to 2 divided by L f of t. All right, I forgot something here. It's starting from 0 to L. All right, f of t dt. Now the second step is to find an equal to 2 divided by L from 0 to L f of t. Always remember the an goes with cos. All right, good. And then bn equal to 0. When it's even, your bn is equal to 0, so you get already the marks. You don't have to find it like this. All right, so if you've identified, no, this function is even, like that one, all right, you're gonna say bn equal to 0. Just writing that, you have your mark. All right, and then you apply these two rules, and then you get your answer. It's gonna be more faster. All right, so now if it's an odd function, it's even more less. All right, because a odd function, what you will do is your a0 is already 0, you know it, and your an is 0, you know it. You see how easy the things become, and then you have to find only bn, right? That's it. But before finishing this introduction, all right, I want you to come here to know a little bit about some, because we will be dealing with integral. All right, I just want to show you something quickly. Integral of, for example, sine of a t, okay, dt is the same as 1 over a cos of a t. All right, obviously plus c, okay, blah blah. I just want you to know that it's become like that. So in case I'm having sine of n pi t, all right, dt, I'm gonna get minus 1 over what? N pi, all right, cos of n pi t plus c. All right, and then cos, integral of cos n pi t is gonna give me positive, cos here when you do integral, it's gonna be positive sign. All right, okay, I just wanted to show you this before we continue. All right, okay, good. So I'm gonna erase this part, and I want to show you some few stuff here, because you will come across this. You'll come across sine of n pi. This sine of n pi, it will always give you 0, because, all right, this is your calculator. If I press sine, please put your mode on radians. Sine of pi, it's give me 0. No matter if I put n, if n equal to 0, obviously it's gonna give you 0. If n equal to 1, it's gonna give me 0. If n equal to 2, it's still giving me 0. If n equal to 3, it's still giving me 0. You can see that in my calculator, right? So when you see sine of n pi, you can directly replace it by 0. All right, now this is number 1. Number 2, if you see cos, it's gonna come a lot, of n pi. What this, it's gonna give you what? Now here you have to do some studies. Let's start by cos of 1. All right, it's gonna give you what? Cos of 2, it's gonna give you what? Cos of 3 pi, it's gonna give you what? And cos of 4 pi, it's gonna give you what? All right, now when you press your calculator, cos of pi, it's give you -1. All right, if you press cos of 2 pi, it's gonna give you 1. Cos of 3 pi give you -1, and cos of 4 pi give you 1. This is the same as writing -1 exponent n. Okay, -1 exponent 1, -1 exponent 2, because it's 2, -1 exponent 3, -1 exponent 4. So obviously, -1 exponent 1 is going to give you -1, -1 exponent 2 will give you +1, -1 exponent 3 will give you negative, and so on. All right, so this can be written as -1 exponent n. So every time you see cos of n pi, you can reduce it as -1 exponent n. All right, and we're gonna continue. So let me just quickly do this, show you from this. All right, I want you to remember this. If you can't remember it in a test, please redo it like this with your calculator, so that you can generate your own formula, please. All right, so this is basically the first part of our lessons, and then we're gonna tackle the real question. We're gonna solve maybe 3 questions, when 1 general, 1 even, 1 odd. All right, you will see it in the other video. Thank you for watching, and be tuned.